Hello class. For this lesson, we're going to recap on what we had learned about energy stores and transfers and what we had actually covered from worksheet 7.1 in the last lesson. So you may recall this example where we have the boy throwing the ball from A to B, and assuming that we took the height equals 0 at A, then we know at the very start there is no GPE at point A. However, since the ball is moving at 12 meters per second, we do remember that since the ball is moving, therefore there must be kinetic energy. And you also recall that once the ball reaches the maximum height, there is no more speed or velocity, and hence no more KE. But since there is a certain height, we can therefore say the energy stored at B is the gravitational potential energy. Hence, from that previous example, you recall that we actually have the kinetic energy that is actually converted to gravitational potential energy, and hence we can actually form the equation half mv squared equals to mgh. We established in the last lesson that the mass is not consequential at all, and hence we are left with this equation where we have half of 12 square equal to 10 times h, and therefore h equals to 7.2 meters. Okay, so this is what we did in the last lesson. I hope you can actually recap very quickly on this, and we will move on to the next slide. You also may recall this particular example where I said that we don't always have to fill in the blank with anything, especially if we do know that there is no particular energy store we are interested in at that point in time. So therefore, we're going to leave the left hand side, this column here, blank because we know we're not interested in any particular energy store at all. In order for the boy to throw the ball, we already established that there needs to be work done as an energy transfer, and therefore after the ball is thrown, just as it leaves the hand at 12 meters per second, we know that the ball possesses kinetic energy as an energy store. Okay, so this is where we stop from the lesson itself, and I ask you to go home and think about what is the amount of energy required from the man. And if you recall the previous example, we can basically form the equation as long as we know what is the energy that is involved. And in this case, the energy that we're looking at is actually the work done, which is converted into the kinetic energy within the ball. So from here, all you need to do is to equate work done equals to half mv squared, and therefore we can now form an equation. Now, since the ball, remember I asked you to change to 200 grams, you will need to work with kilograms, so you have to change it to 0.200 kilogram and multiply by 12 square. Okay, don't forget the least SF rule, and hence what we are doing here, we are actually having about 14 joules of energy required. Okay, so for question E, all we are doing from here is to actually understand what happens all the way from A to C. Okay, so what we are saying is that the man transfers work done to the ball. I know at this point it sounds grammatically wrong. Not to worry. We just want you to have the idea that work done is an energy transfer, and hence we say the man transfers work done. And this is converted into kinetic energy in the ball at A. And as a result, the ball moves until all of this kinetic energy is converted into gravitational potential energy, which is what we did earlier at A and B itself. Okay, so I hope that is quite clear. Now, if you look at the food for thought question, and this is something I will definitely be asking you when I come back next week. So, is it wrong to include chemical potential energy in the man is transferred to the ball? After all, the man does have chemical potential energy. Can we say that we transfer this CPE to the ball? Think about it, and I'll ask you guys the very next week. Alright, at this point, this is where maybe I would ask you to pause the video so that you can take a look at the question. Please do pause the video and try to fill in the blanks by yourself. And when you are ready, then I will ask you to play the video and I will go through what we're trying to understand from this question. Please pause the video now. Okay, welcome back. So we have the ball now is actually falling from a certain height, and the first part asking you where should we set the reference height where h equals 0. So you have to choose between A, B, or the ground. I think what we are more interested in is, should I choose B or should I choose the ground? For those of you who thought it would be the ground itself, that is not a good idea, because you realize that if I want to try to find a GPE based on the ground, then we have no idea what is the height of the ball from the ground at all. So it does not make sense for us to even use that as a reference point. Okay, so therefore we actually want to use B as the reference point. Okay, now then from here we want to find the energy stored in the ball at A and the energy stored in the ball at B. You realize that at A, and if B is the point where H equals 0, there must be a GPE at A. But not only that, at A the ball is also moving. So in this we have two energy stores at A, the GPE as well as the KE at A. And finally, when the ball reaches B, since the height equals 0 at B, we therefore can say that the final velocity must be 3.3 meters per second, and hence the ball only has the kinetic energy as a energy store. So from here, same thing, please pause the video, look at what we have in the previous question in part A, and try to form your equation first before you carry on with the video. Please pause the video now. Okay, and welcome back. So this is what you should have. Remember, we had GPE plus KE, and this is all at point A, would equal to the kinetic energy at point B. Okay, so if you look at the entire equation, I hope that you can see that we will do away with the mass completely. So we have something like half v squared at A equal to half v squared at B. Again, bearing in mind, the mass is completely cancelled out in this equation. So all we have left with this equation, 10h, which is what we are trying to find, plus half 3.3 square equals to half 1.2 square. Okay, so if you were to solve for this entire equation, you should be getting something like the height is 0.47 meters. Okay, so that is how you really take a look at the entire context. Make sure you know what is the energy we are looking for at the very start. Look out for what is the energy that it possesses at the very end, and you will always be able to form the correct equation to find the necessary physical quantities that you need. Okay, I'll be going through one last example before I will be expecting you to do the rest of the worksheet as a checkout activity. So if you look at the next question where we are bringing a box or a load up to a certain height. Now, one way is to push it up a slope, and the other way is to just lift it up vertically with a motor. Okay, this is one particular question that is quite important, because many times many students would think that, oh, okay, one way could be harder than the other. Okay, now there's one thing that's very important here. It does say assume all energy loss is negligible, meaning to say we are not interested in friction of any kind. Okay, so method A, method B, again pause the video here. Think about what are the energy stores when the box is at the bottom. Okay, so that means you may want to ask yourself, is there any energy store? Is it just a blank? So that's something for you to think about. And then, of course, when pushing up the box or lifting up the box, what kind of energy transfer we are looking at? And finally, of course, when the box is at A2 or at B2, what kind of energy does it have? And so if you have actually left the boxes blank, fantastic. For the energy store at A1 and B1, it is completely nothing. We are not interested in any of those. What we are interested is there is work done on the box for method A, because we have to push the box a certain distance with a force, and hence the box will gain gravitational potential energy once it is on the top. And likewise for method B, the motor will actually have to use a force. There's some force on the cable itself to pull this particular box up. So hence there's again work done on the box. And once the box is raised up to that certain height, that box would have an energy store of gravitational potential energy. So from there, you would be able to answer the question. And from here, I would like you to check that you are now able to really understand when to use energy store and energy transfers. And because of these two kind of energy, you are able to form equations. Hence, you are now able to solve for the various physical quantities that the questions were asked for. Okay, so what you need to do from here, I ask that you complete the checkout activities on page 6 and 7, and perhaps you may want to take a short break before moving on to the next energy SLS lesson, which is titled Energy Efficiency. Okay, so please take the time to really recap, revise a little bit of what you have learned about energy, and I'll be seeing you guys next week for normal lessons again. Okay, see ya, bye bye.